Einstein's photoelectric equation, energy quantum of radiation. In 1905, Albert Einstein published a paper that explained experimental data from the photoelectric effect. He suggested that the radiation energy is built up of discrete units, the so-called quanta of energy of radiation. This discovery led to the quantum revolution. Einstein was awarded the Nobel Prize in 1921 for his discovery of the law of the photoelectric effect. He explained, if an electron within some material absorbs the energy of one photon and acquires more energy than the work function, the electron binding energy of the material, it is ejected. Each quantum of radiant energy has energy h nu, where h is Planck's constant and nu the frequency of light. In photoelectric effect, an electron absorbs a quantum of energy h nu of radiation. If this quantum of energy absorbed exceeds the minimum energy needed for the electron to escape from the metal surface, work function phi naught, the electron is emitted with maximum kinetic energy. K max is equal to h nu minus phi naught, equation 1. Intensity of light of a given frequency is a measure of the number of photons incident per second. Increasing the intensity will increase the number of emitted electrons per second. The energy of the emitted electrons does not depend on the intensity of the incoming light, but only on the energy equivalent frequency of the individual photons. K max depends linearly on mu and is independent of intensity of radiation in agreement with observation. Equation 1 implies that photoelectric emission is possible only if h nu is greater than phi naught or nu greater than nu naught, where nu naught is threshold frequency. Phi naught is equal to h nu naught. There exists a threshold frequency. Nu naught is equal to phi naught upon h for the metal surface, below which no photoelectric emission is possible, no matter how intense the incident radiation may be or how long it falls on the surface. Above the threshold frequency, the maximum kinetic energy of the emitted photoelectron depends on the frequency of the incident light. Using relation K max is equal to E V naught, we can rewrite equation 1 as E V naught is equal to h nu minus phi naught for nu greater than nu naught. V naught is equal to h upon E nu minus phi naught upon E. It shows that the V naught versus nu curve is a straight line with slope is equal to h upon E independent of the nature of the material.